Welcome. I would like to thank the organizers for inviting me to share some of the data that we have obtained in our lab. And I would like to share those data regarding genetic polymorphisms in carcinogen metabolizing enzymes in relation to individual cancer risk. My name is Godschalk. I work at the Department of Pharmacology and Toxicology at Maastricht University. So when we talk about carcinogens, we are daily exposed to all kinds of carcinogens. Sometimes it's voluntary, like in smokers, but most of the time it's involuntary. Think about passive smoking. You eat contaminated food products, occupational exposures. Actually, at a sunny day, if you walk outside, you have UV radiation, and that can damage your DNA in the skin. But also gasoline exhaust or diesel exhaust. If you're standing next to a car, you inhale those exhausts that can lead to exposure to compounds that can either cause cancer or can damage our DNA. Since we are all exposed to these compounds, but we still also know that a lot of people don't get cancer, right? And one example, I think a very nice example in history, is Winston Churchill, right? So Winston Churchill, he actually became 91 years of age. But we also know that he smoked a lot, right? He smoked every day. Actually, most of the pictures taken from him, he's having a cigar in his hands, right? So already indicating that he smoked a lot. Still, he reached the age of 91 years old. And this is, of course, quite surprising, right? Because if somebody has such a stressful life, how can you get to this age? Why didn't you get cancer much earlier? Right? So this is how we deal as a human body with carcinogens. So if we look at this, we are all exposed to those pre-carcinogens. These pre-carcinogens can then be metabolized in our body. And most of the time, the body metabolizes these compounds to water-soluble derivatives that can be excreted in the urine and the feces. And then they are not dangerous anymore. On the other hand, these carcinogens or pre-carcinogens can be metabolized to reactive metabolites. So that's much more like a mistake made by your body. These reactive metabolites can bind to the DNA. That can lead to mutations, and mutations are the driving force behind the development of cancer. So it is actually the balance between whether you form more water-soluble compared to reactive metabolites. That balance determines your cancer risk. And maybe in Winston Churchill, the balance is much more to the water-soluble derivatives compared to the reactive metabolites. So this is something we wanted to investigate in more detail, right? We want to understand why some people get cancer early and others get cancer at a very old age or not at all. So the whole idea here is, or the concept is, that if you do not have an exposure, your genetic makeup does not make any difference, because you will always have a low background level of, for instance, developing lung cancer. However, if you have an exposure, for instance, to cigarette smoke, and you have the resistant genotype, your cancer risk will still be increased, but not as much as compared to those individuals with a sensitive genotype. Right? So Winston Churchill, maybe he had a more resistant genotype, which made him having more metabolism towards water-soluble derivatives. The genotype that we would like to focus on in this presentation is myeloperoxidase. Myeloperoxidase is an enzyme which is present in neutrophils, and it is involved in the defense against bacteria. Right? So if you have a lung infection, the neutrophils, these cells are attracted to the lung and they release the enzyme myeloperoxidase. The bad thing is that myeloperoxidase is also capable of activating compounds in cigarette smoke, and they form these reactive metabolites that can damage the DNA. But there is a genetic polymorphism in the promoter region of myeloperoxidase. And the promoter region determines whether the gene is switched on or switched off. And if you have in the sequence of the promoter region a G, then you have a high activity of MPU or a high transcription. And if you have an A, you have a low activity of MPU. And there are already epidemiological studies that showed that the people carrying the MPO-AA genotype, that they have a lower cancer risk compared to people with the GG genotype. Right? So a higher activity of myeloperoxidase leads to a higher metabolism of the compounds in cigarette smoke to DNA damaging compounds, more DNA damage, and therefore a higher cancer risk. That's the concept. To study this in more detail, we wanted to do a study by measuring not cancer, but measuring DNA damage in lungs. Right? So we took smokers, because smokers, we know that they are highly exposed to cancer-causing agents. We isolated DNA from their cells from their lungs, bronchoalveolar lavages actually. And we then determined in the DNA, we determined the MPO variant, and we measured the DNA damage in these lung cells. Right? So, and then the idea is that those individuals who are exposed and have the high activity MPO variant, those will be also the people that have higher levels of DNA damage, and that would lead to a higher cancer risk. On the other hand, those people with the low activity alleles, so the AA, MPO-AA variant, they will have, we expect, lower levels of DNA damage and thus a lower cancer risk. So we had people that smoked, lung patients, and what we did in those patients is we took a so-called bronchoalveolar lavage, with which we can obtain cells from the lungs, and in those lavages there are epithelial cells, but also those inflammatory cells. So these cells, we then isolated DNA from those cells to measure either DNA damage, and we measured also the MPO polymorphism, so whether the people had the A allele or the G allele in their DNA. And we made sure that we had a similar number of individuals with the different genotypes, right? So we had 11 people with the MPO low activity genotype, and we had 11 people with the high activity genotype. And we think that those people with the heterozygote genotype, that they have an intermediate activity of myeloperoxidase. Similar numbers of males and females, also a similar age in the three groups. However, cigarette smoking, the people with the high activity genotype, they smoked a little bit less, but that's also what we need to take into account, the number of cigarettes smoked per day. And that I will show you later on how we dealt with that. So this is the first result. On the x-axis, you see the different genotypes. On the y-axis, you see the amount of DNA damage in the cells that we obtained by the bronchoalveolar lavage. And what you see is that DNA damage is higher in the individuals with the high activity myeloperoxidase variants compared to those with the low activity variants. And this difference is statistically significant. But then, as I mentioned, those people with the high activity genotype, they smoked a little bit less than the others. So what we also did is we took the amount of cigarettes smoked into account. Right here you see the amount of cigarettes smoked per day on the x-axis and the amount of DNA damage on the y-axis. And you see that there is some trend. So people that have a higher dose, smoke more, have a tendency of having higher levels of DNA damage. But it is not necessarily so, right? We also have people down here that have much lower levels of DNA damage. However, if we now put in the information that we have on the MPO genotype, and we look at the dose response, so how many cigarettes smoked versus the amount of DNA damage, then we see that those with the high levels of DNA damage are, in general, those individuals with the GG genotype, and those with the low amount of DNA damage, so the lower formation of adducts per cigarette smoked, is actually in those individuals with the AA genotype. And so this is a clear example that the dose determines the amount of damage, but on top of that, that the genetic polymorphisms plays an additional role. So in conclusion, genetic polymorphisms affect DNA damage formation in smoking individuals, and we looked specifically at myeloperoxidase, and the myeloperoxidase AAAG genotype can determine the dose response in bronchoalveolar lavage cells of smokers. So this is again Winston Churchill. He had a very stressful life. He smoked a lot, he drank a lot. Still, he reached a reasonable or a very high age, I would say, for his lifestyle. And we think that genetic polymorphisms may, at least in part, play a role in determining whether you get cancer at an early age or cancer at an old age. So if you feel interested in this subject of research, you can always contact me via email. But for now, I think you can ask your questions and I'll be happy to give you the answers.